and at omega equals to omega UGB, UGB is unity gain bandwidth. Here our gain in dB, gain in dB equals to 0 dB. That is, gain is actually in magnitude, gain is 1. Okay, now we will put this equation in this. So this is our magnitude in dB, which is 0 dB, equals to 20 log, this is our DC gain, plus 20 log omega p minus 20 log omega UGB. Okay, now we can write it like this: omega UGB, 20 log omega UGB equals to 20 log A naught omega p. Because these are plus, so this will be you can say multiplication, and we took UGB term on left side, so 20 will cancel, we cancel log omega UGB equals to A naught omega p. So this is known as gain bandwidth product, and we have seen omega p equals to omega minus 3 dB as well, because this is a 3 dB frequency. So so this is known as gain bandwidth product. Okay, so now we draw our Bode plot for this. Okay, so this is say our omega p, and this will actually like this, something like this will, okay, and this is A naught minus 3 dB, this is A naught, so magnitude in dB. Okay, and this is minus 20 dB per decade roll off. This frequency is omega UGB. Okay, and now on this line, say these are the gains at different frequencies. Say we consider this, say this is AX and frequency is omega x. So this will satisfy this equation on this 20 dB roll off. So omega x into AX equals to omega UGB. Okay, so any point on this line will satisfy this equation actually. From here, from this point to this point, I mean even this till another pole or 0 comes, this will satisfy this equation. Now let's draw phase plot. Phase plot for single pole system we have already seen, and okay, so this is say 0.1, say this is 10, this is 0.1 omega p, this is 10 omega p. So we draw. So this is 0, this is 90, and this is minus 45, this is phase, and this is omega x. Now so this is our phase plot. Okay, so now here I will just give you definition of phase margin. So say this is 180 degree phase shift. Okay, now at omega UGB frequency, how much margin with respect to 180 degree is left in phase shift is known as phase margin. So this is phase margin actually. So phase margin is here will be minus 180 degree minus 90 equals to minus 90 degree. Okay, it will come like positive. So here basically we subtract this one. Okay. So basically with respect to this, how much is this basically? So this is 180 minus actually 90, because phase shift is 90 degrees, so it will come like a 90-degree phase margin. So this is definition of phase margin. Mathematically how, or graphically in plots, how we will see. So distance between, or difference between these phase shift and minus 180 degree is actually a phase margin, and this is important parameter to check stability. So and usually when you do simulation, and you find out from simulation how much phase margin is there. Okay, so here we have seen this Bode plot for single pole system, and in previous video we have seen why single pole system is important and why we study single pole system, and we have considered different cases, and this is basically case 1 when omega is much less than omega p and our gain is near omega naught, and gain at omega equals to omega 2. Case 2, then when omega greater than omega p, there is a minus 20 dB of roll off. Then at omega UGB, we find out our case 4th at omega equals to omega UGB, our this is 0 dB, gain should be 0, and we find out this gain bandwidth formula, and we have seen here on this omega p2, once this first pole occurs, and when there is a minus 20 dB per decade roll off is occurring, then at any point on this line satisfy this formula actually. Now suppose uh, you take 2 points, say omega x1, omega x2. For omega x1 gain is a1, for omega x2 gain is a2. Okay, so then it means for single pole system, omega x1 into a1 omega UGB and omega x2 a2 equals to omega UGB. So if you divide both, then omega x1 upon omega x2 equals to a2 upon a1. Okay, so for single pole system, when roll off is minus 20 dB, omega inversely proportional to gain. Okay, so this is line, so this is gain, say a, this is omega. So for all cases this will satisfy this equation. So this is important point, note this point, this will be used for calculation purpose. Now suppose there are two poles, so first pole is giving minus 20 dB per decade. Now second pole occurs here, this is first pole, this will go by minus 40 dB per decade. Now say third pole is occurring, so this is omega p1, omega p2, omega p3, and this will be minus 60 dB per decade. So here my slope is not very good, I will draw once again. So this is like this, then this, so this is minus 60 dB, minus 40 dB. Okay, if we consider this is only a two pole system, so it will be like omega square inversely proportional to 1 by a. Okay, so omega 1 upon omega 2 square equals to a2 by a1, say at this portion of plot. say this is omega